All right, so what we're going to do in this segment is we're going to look at, we're going to continue learning about the graphs of logarithmic functions, and we're going to focus on horizontal left and right translations of the graph of a logarithmic function, okay? Now, you may have already seen the segment on vertical shifts of a logarithmic function, but we are leaving that out at all. If you haven't seen that video, it's not going to matter. You're still going to be able to learn about horizontal shifts even if you haven't seen the segment on vertical shifts. Okay, we're only focusing on horizontal shifts. Okay, now when we learned about exponential functions, right? Let's say we have an exponential function with a horizontal asymptote and it curves up, goes steep, goes through the point 0, 1, right? 0, 1, and then horizontal shifts. What we saw is that if we did a horizontal shift, okay, what we did was we looked at this point, this 0, 1, and we wanted to see how far to the right or to the left did it move over, and that was your horizontal shift, okay? And if you recall, when we did the exponential, let's say it was f of x is equal to, that's ugly, f of x is equal to 2. You know, let's say that this was a positive 6 shift, right? Then what we would do is in the exponent with the x, we would put minus 6. We would put x minus 6 to indicate a positive 6 or a rightward shift of 6 units, right? So the way that we identified a horizontal translation of an exponential function was by the movement of the point, this important point on the graph of an exponential function. But notice also that when we did that, the horizontal asymptote did not move at all. It just went, because it was a horizontal shift and a horizontal asymptote didn't change at all. It just moved to the right, but moving to the right means it's still on top of itself. Okay, so there is no shift at all in the asymptote, but there is a shift in this point. Okay, well, a horizontal translation of a logarithmic function, because a logarithm is the inverse of an exponential function, now what's going to happen is that the point is not going to become as important, and what is going to be important is going to be this the asymptote. We're going to look at the asymptote because we're going to see that because logarithmic functions have a vertical asymptote. If you were to move sideways, that vertical asymptote would move with the graph. And so the vertical asymptote is going to be what tells us about our rightward shift or our leftward shift, okay? And so I have one ready to go right here. All right, go over here. You can see we have this graph of a logarithmic function, and you can see that that it goes vertically down, right? Okay, and it flattens out to the right, so we know that this has a normal. This is kind of the normal shape. There are no reflections in this one. Okay, it's not going to have a negative on the logarithm. It's not going to have a negative on the x. Okay, this is the normal shape. So because the asymptote is so important with a horizontal shift, the first thing that you need to do is draw in the vertical asymptote. And you'll see that the vertical asymptote is not on the y-axis, which is way over here. So it's hard to see the vertical asymptote sometimes. What you have to do is you have to go to the place where the graph is going vertical. Okay, now be careful here because many students look at this and they think it's a horizontal asymptote. This is not a horizontal asymptote. Look, that has an upward curve to it. This is not going completely flat, okay? But it is going completely vertical here. Once it gets to about right here, it basically becomes a straight line. That's what you're looking for. Wherever that straight line is, you are going to draw in a vertical line, okay, which is the vertical asymptote. And so now you have identified the vertical asymptote, okay? Now, before we identify the left or the right shift, let's go ahead and identify the base of this logarithm. Identifying the base works exactly the same way, except instead of doing it off of the y-axis, you're going to base it off of the vertical asymptote. So from the vertical asymptote, we're going to go 1 unit over, and then we're going to go up or down until we get to the graph, which is right here, and there is what I call the point. That is the very important point, and every single exponential or basic exponential and logarithmic function has that point. from that point, we have to go 1 unit either up or down. Okay, if we go down, we're not between the curve and the asymptote. We need to go to where we're between the asymptote and the curve. So we're going to go 1 unit up, then over to the asymptote like we always do. Then from there, we're going to draw along that line. That's 1 unit up until we get to the curve, which is right here. And that's a distance of 1, 2, 3. So this logarithm has a base of 3. Okay, so we know that this is going to be f of x is equal to log base 3, okay? Now, this does not have a vertical shift, and I'll show you why. It's because the point is still on the x-axis. Remember, well, you haven't seen this yet, but if there's a vertical shift, the point will either be above the x-axis or below the x-axis. But so we're not dealing with any vertical shifts here. What we want to do is we want to identify the horizontal shift. And the horizontal shift always goes with the x inside the parentheses. And it's always going to have the opposite sign. It's going to reverse the sign. So if it's a +2 shift, it's going to be -2. If it's a -7 shift, it's going to be +7. Just like all of the shifts, all of the horizontal shifts that we deal with in algebra. Okay? So how do we determine the horizontal shift? Well, what you're going to do is you want to see how far is the asymptote from the y-axis, because it used to be on the y-axis. Well, from the y-axis, this one is this far, okay, and that's 1, 2, 3, 4, 5. It's +5. That's a +5 shift from the y-axis. The new vertical asymptote is 5 units to the right of the y-axis. Therefore, that's a +5 shift. And because it's a horizontal shift, we're going to reverse the sign, and it's going to become x -5. And therefore, the equation of this graph right here is log base 3 of x -5. Now, how would you write this? The way you would write this in a box on a computer would be log, log, no negative in the front because it's not upside down, then underscore for base, then the digit 3, so log base 3, then open the parenthesis and put x -5, close parenthesis, and that is the equation or the expression of the function log base 3 of x -5, okay? Let's try a few more examples. All right, here's another example. If you're feeling pretty confident, you can pause the video and see if you can figure out the equation on your own. Or I'm going to go ahead and work it out now. Well, I know that the first thing I want to look at is I want to see, is it upside down? Is it backwards? Now, it's hard to tell. Here's the thing. It's hard to tell if it's backwards without the vertical asymptote. So the first thing I'm going to do is I'm going to draw in the asymptote. That's usually always the very first thing I do. Well, you can see that this graph goes vertical. It becomes like perfectly vertical right here, and therefore that is the vertical asymptote. Okay? All right, good. Now, notice that the graph is on the right side of the vertical asymptote, and it flattens out off to the right. That must mean that it is not backwards, because it is only backwards if it's on the left side of the asymptote. But I do notice that the vertical part of the logarithm graph is actually pointing up instead of down. Normally it points down. Now it's pointing up, so I know that this one is upside down. So I know that this function is going to be f of x is equal to negative on the log, right? Negative on the log, okay? Because it's upside down. But we're not going to put a negative on the x, okay? Now, by the way, the negative on the x is going to become a very interesting special thing in this particular class, okay? So please be very careful about that. All right, so now what we're going to do is we're going to identify the base. We want to see what the base is, and so we're going to go 1 unit over from the vertical asymptote, and we're going to go down, and we're going to hit right here, okay? And so here's the point. And then from there, we're going to go 1 unit up or 1 unit down. Well, we want to be between the curve and the asymptote, so we got to go 1 unit down, then go over to the asymptote, and from here, we're going to measure the distance over to the curve, which is right about there. Now, be careful. You may think you can just look at this 7 and know that it's a log base 7, but it's not. This is why I don't just use whatever numbers on the graph. I need to count the distance. The vertical asymptote has moved over, therefore it's not a distance of 7. This is a distance of 7 from the y-axis. I need to know what the distance is from the asymptote, which is 1, 2, 3, 4, 5. So this is a distance of 5. That makes this logarithm a log base 5, right? And now we're going to put in parentheses, we've got to find out our horizontal shift. Well, here's the vertical asymptote and here's the y-axis. Well, what is the distance from the asymptote over to the y-axis? Well, that's a distance of 1, 2. In what direction? In the rightward direction. That's a positive direction. So this is a plus 2 shift sideways, horizontally, right? And therefore, I'm going to put x minus 2 in the parentheses, x minus 2. And that is the equation of our function. And so if you were going to put it in in a computer, you would put negative log base of 5, right? So negative log base underscore, that's an underscore, base 5 in parentheses of x minus 2, and we're done, okay? Let's try a couple more examples. What we're about to see is something that is probably going to be a little confusing, but you have to follow, just be very careful, very cautious to follow the directions exactly how I give them to you, and you should be just fine. Okay, here's another example. If you are feeling pretty confident, why don't you go ahead and try and do it on your own, but be ready to possibly change your answer a little bit because there's something in this one that you haven't seen before. All right, so like I said, the first thing I like to do with these is draw in the asymptote. Okay, so it goes vertical right here. You can see it goes very steep, practically a straight line right here. So that must be where my vertical asymptote is. I'm drawing my vertical asymptote right here. Good. Now, my graph is on the left side. It's not on the right side. Normally it's on the right side. Now it's on the left side, so I know that this one is backwards. That means there's going to be a negative on the x that is inside parentheses. Okay? But here's the problem. Do you remember when we did exponential functions, when there was a negative on the x, we would write, like, let's say that it was 5 to the power of, let's say it was backwards. So we would put the negative, but then in the parentheses, we would put like x plus 2 or something like that, right? Okay, so we'd have the negative on the outside of the parentheses. Well, with logarithms, when we write logarithms, we write log base, 7 of, and we put the x inside the parentheses, right? And we can put a negative on that x inside the parentheses. But what if it was x plus 2? Well, here's the problem. I would need extra parentheses. I'd need to do log base 7 of negative, then new parentheses x plus 2. Because the negative has to be on the outside of the parentheses. But that first parenthesis, do you see these parentheses right here? Those parentheses are not there for the x. Those parentheses are there for the log. So I need the parentheses for the log, and I need the parentheses for the binomial term x plus 2. And so I would have to write this as log base 7 of parenthesis, negative, parenthesis, x plus 2, close parenthesis, and then I'd have to close the parentheses again. This is why it's going to be weird. Whenever you have a backwards and a horizontal shift, you have to have parenthesis, negative, parenthesis, and then you have to close off with 2 parentheses, okay? I'm telling you now, and now I'm going to show you in another minute that in this problem we're going to have to do that, okay? All right, so we've got our vertical asymptote here. Let's go ahead and identify our point. We're going to go 1 unit over from the asymptote and travel along this vertical line until we hit the curve, which is right here. So this is the point, right? All right, so now we got to go, to find the base, we got to go 1 unit up or 1 unit down. We're going to go 1 unit up because we want to be between the asymptote and the curve. So 1 unit up is right here. Go over to the asymptote right here and then measure the distance over to the curve, which is right there, okay? Now you can see that this is 1, 2. It's more than 2, but it's not quite 3. More than 2, less than 3, closer to 3. That makes this e. That makes this one a natural log, right? So this is going to be f of x, that's supposed to be an f of x is equal to, now, something I forgot to mention is we said it was backwards because it's on the left side and it's pointing to the left, but is it upside down? Well, the vertical part is going down, right? That means that it's normal shape. This is not upside down, okay? So we're not going to put a negative on it. We're just going to jump right in with ln. Now, I'm going to open a parenthesis. That's the parenthesis for the logarithm. Now I need the negative that for the backwards, and now I need another parenthesis for the x, okay, because I have a horizontal shift. All right, so now what is my horizontal shift? Well, here's the vertical asymptote, and here's the y-axis. Instead of the asymptote being on the right side, it's on the left side. That means there's a negative shift of the vertical asymptote. How far? Well, this distance here, from here, 1, 2, 3, that's a negative 3 shift, and therefore we're going to put it in as x plus 3. There we go, because we're reversing the sign. And now, note, I have 2 open parentheses, 1 closing parenthesis. I need 1 more closed parenthesis, and now I'm done. That is the equation of this graph right here. Okay, the way I would write it into a computer would be ln open parenthesis minus open parenthesis x plus 3 closed parenthesis, and this would give me my correct answer. Okay, you're going to have to practice with this a few times. Don't just give up. Don't just tell me I can't do it. Oh, I can't figure out. It's too confusing. You're going to keep practicing until you get it right. Okay, got to be able to get this right. Okay, let's try just one more example. All right, so let's see. The first thing I like to do is I like to draw in the vertical asymptote. You can see that this graph goes vertical right here. So I'm going to draw in the vertical asymptote right there. Okay, good. Now, I can see a couple things here. First of all, this graph is going vertical in the upward direction. That must mean it's upside down. It's also on the left side of the asymptote, and it goes flat to the left. That means it must be backwards as well. So this is upside down and backwards, right? So this graph is actually going to be, it's going to have a negative on the logarithm and a negative on the x. And because it's backwards and it has a horizontal shift, it's definitely going to need double parentheses, okay? All right, so let's find the base. We're going to go 1 unit over from the asymptote and go up to the, and go up or down to the curve. We're going to go up to the curve right here. Interestingly, the point, that important point, happens to be going through the origin of this graph. That happens sometimes. It could be a little confusing, but ignore the, for now, when identifying the point, ignore the y-axis, ignore the x-axis. You're just going 1 unit over and going to where it intersects the curve, okay? All right, so now to find the base, we're going to go either 1 unit up or 1 unit down. We're going to go 1 unit down, and we're going to go over to the asymptote right here. Now, do not count from the y-axis. You are counting from the asymptote. From here over to the curve, which is right there. Count the distance. 1, 2, 3, 4, 5, 6. This is a distance of 6 from the asymptote. That means this has a base of 6. So this is going to be f of x is equal to negative, because it's upside down, log base 6, okay, of, now, it's backwards, so we're going to put a negative, right? And we also know that we have to put the x binomial inside some parentheses, right? And we know we want to close it off with 2 parentheses. We need another parenthesis to close off the logarithm. So this is what our answer is going to look like, and now we just got to put in here an x with a plus or minus a number. Now we just need to know the horizontal shift. All right, well, here's the vertical asymptote, and we got to find out how far is it from the y-axis. Well, here's the y-axis. That's not a very long distance at all, right? Okay, in fact, it's 1 unit. From the y-axis to the asymptote is 1 unit, and the asymptote is on the right side, so it went plus 1. Okay, the asymptote is plus 1, but we have to reverse the sign because it's with the x. It's a horizontal shift, so we're going to put minus 1. And therefore, the equation of this graph is negative log base 6 of negative of x minus 1, closing off with a couple parentheses, okay? All right, that's it for horizontal shift. What we're going to do in the next segment is we're going to put together the vertical shift with the horizontal shift with the reflections and the base. And I'm going to have a procedure over here on the side that you can write down and follow that will help you identify the base, whether it's upside down or backwards. What is the vertical shift? What is the horizontal shift? And then we're going to write out the whole function, and then you will know how to identify the function of the graph of a logarithmic function.